Hi everyone, my name is Yaobin. Today I want to present a paper, Towards a Generic Method of Evaluating Game Levels. Let me first introduce the topic. So automatically evaluating the quality of the game levels is really useful. Here, the game levels is the same as game maps. So the quality of game levels should be the playability or interestingness of the map. It's so useful because we can give feedback to the designers as soon as possible. And more importantly, we can use it in procedural content generation algorithms. So what is the algorithm? It means the levels or maps are generated on the fly, not pre-made. This can reduce the game size, so it's so popular. So if we want to enable the game general procedural content generation methods to plug in any game, what should we do? It requires the game to design a map by itself. So how to do that? The game should know what is the best map to make and how to do that. And we're gonna find out. Some games have evaluation functions, but not general. They are domain specific. And this paper gave a generic solution inspired by game design patterns. And then the game demonstrated with two different kinds of games. In related works, domain-specific game design patterns has been used to describe levels in role-playing games as well as first-person shooter games. Procedural game content generation has been used in the creation of game levels for existing games such as StarCraft. It uses search-based process, uh, genetic algorithms, which is a search heuristic. It requires a evaluation function to select the most appropriate content for reproduction. So it's an optimization problem. Here, the problem is how to create the best map. Two previous authors proposed a generic framework for level generation using a genetic algorithm, but it has limitations. The two figures below here basically shows us one popular game layout. So each player, there are two players here. Each player is expected to start at a random base tile, so the two white position on the map, and then collect the resources, the blue parts, and in order to destroy the other space. Uh, then we can see the left figure is the abstraction version of the right one. The left one is map sketches. It is just abstract the complex game levels into their basic building blocks. It consists of the grid of layouts with small number of tiles. It has empty tiles and the impassable tiles and special tiles, which is bonus or resources, which is domain specifics. And how to evaluate such maps, the simpler version. The reason why we want to do the transition is that we want to uh, demonstrate a simpler version of the matrix, but we can definitely using the matrix for any other maps in the future. So how do we create the matrix? We found some high-level guidelines from great game design patterns. There are three of them. First one is symmetry. It means that each player has equal opportunities. Area control means we should put control over access, action availability, and resources related to each area. Exploration means we assume map is partially certain. The players explore the map for a specific goal. Area control and exploration require a set of two or more tiles identified as the reference tiles. Usually, they are used as a player basis. Let's see the left figure here. The triangles are the basis of the player. the red one and the blue one, the two players starting points. And the control measures define safety as to describe that a tile is close to which reference tile, so which base. For example, uh, in the second figure, the red tiles are tiles close to the red triangle, and the blue ones are close to the blue triangle, and the white ones should be uh, between them and have the same distance to the both position. And we can see the equation. The first equation is the calculation details of the safety from any tile T to a base I. And from the equation, we can see that from any T to the closest I, the safety is positive. Otherwise, it will be 0. And the third method is the exploration method. It is the sum of a exploration between bases. It basically uses the map coverage with four-way flood field algorithm. So how does the flood field look like? So basically it starts from the base point and then it go over all the tiles around. It looks like a flood until the flood reaches the target position, the other triangle, and it stops. So these two figures show the flood from the red one to the blue one and the blue one to the red one. And finally, we add them together to be the value of the exploration measure. So the higher or the larger the exploration measure is, the longer the path is, or the winding the path is. Finally, we reached our matrix formulas. Uh, First one is FS, which is the strategic resource control. Uh, let's look at the formula here. It uses safe safety measure here. And we just discussed the safety measure related to the closeness. Uh, so the smaller the FS value is, the readily accessible resource for the resource is closer. And the second one is FA, error control. Error control uses AI. AI is the map coverage of safe tiles. So the larger it is, the more easily controlled space are near each player. And the third one is FE, exploration difficulty. It uses EI. EI is the exploration coverage of the bases. So the higher FE is, the more difficult the exploration is. And then we have the balanced version of the three formula here. Why do we need the balance? Because we need to ensure the symmetry of the reference tiles or the player bases. Map sketches are optimized towards the measures of quality presented above while using artificial evolution, which is mimics the biological evolution. We don't want to dig into this, but we need to know evaluation formulas can be combined or separated to meet the specific requirement, and playability should be added as a constraint, such as targets should be reachable at least. In order to demonstrate the magic star works, the paper provides two case studies. So the two cases are showing different game runners. The first game is multiplayer strategy game maps, and the good map requirements are resources are easy to reach to each player. Player has enough initial space to move, and the winding and the long exploration path. So the figure A shows that it uses FS, which means that the resources are close enough to the player initially. You can see that, but it does not have ample uh, space to move initially, and the exploration path is simple. And the second one uses FA, means that it has enough space to move initially. But we can see the resources are everywhere, and the path is simple. And the third one uses the exploration, and we can see that the 2 points are far away, and uh, the path could be windy, but the resource everywhere. The last one uses everything, and it's just perfect. The second game is a single player game. Basically, the player travels from the entrance to the exit. In the map, the black areas are impassable, and the red triangles are enemies, and the yellow circles are treasures, and the gray squares are exits and entrance. So the requirements are the treasures should be close to enemies, because every time you uh, just uh, win each battle with enemy, you need the treasure for reward. And the second one is the enemy should be far from entrance, because initially you need some space to move around, not directly in the battle. And the third one is the exploration path winding. You don't want to make the game really simple to really easy by creating too close enough entrance and exit. So let's see, the figure 8 just uses the FS, means the enemy and the treasure are close. They're close enough, but no others. And the second one uses FA, means that uh, the the uh, the entrance and the exit are far from the enemies. And the third one uses the FE, means the exploration path. It's winding, and the last one uses all. And the figures are just perfect to show that. In conclusion, in this paper, we have introduced three generic metrics for game levels: area control, exploration, and balance. We have also shown that it is straightforward to derive specific evaluation functions for a particular game in different genres. Finally, we hope to arrive at the collection of game-level metrics that can be reused in a plug-in manner in procedural content generation. And here's a reference. Okay, that's all for my presentation. If you have any questions, you can ask me on the Blackboard discussion, mm, and I cannot answer you currently. I'm sorry for that. Okay, thank you.